Good day, everyone. This is Shivang from Apps and Data, and today I'm excited to start an exciting series on SQL questions that will help you prepare for live coding interviews. After being interviewed and successfully clearing these interviews, I decided to compile a list of lookalike questions and share them with you. So you could practice, refresh, augment, or even build your skills in SQL. These questions are specifically tailored for a data scientist interview or a data analyst interview, which is tested more on logic and less on syntactical knowledge. Okay, so let's dive in. In this series, I will cover different categories of questions. Sample coding questions, live coded in this video, and also some important theoretical concepts that will come later in the series. For this particular video, I will be showing you how to code level 1 questions. There are 5 questions that will be coded, but there are subparts. So in total, we'll have 9 queries on which we'll writing the code. But before we start, let's review what are the things you need to know before you start the series. So the prerequisites for this particular series is having basic SQL syntax knowledge, where you should know select, from, where, join, etc. You should have intermediate hands-on experience. You should have understanding of data nomenclature like variable, dataset, database. And also, Absent Data has launched its own free SQL practice platform. The URL will be in the next slide that you could use to solve your questions. Then you also need some basic experience of database theory. And just a reminder, analytical interviews are more logic driven versus data engineering role that could be more theory or experience driven. Okay, now it's time to review what are the different question types you can expect in a SQL interview. So we have broken these questions into different parts. The first one is query based, which is live coding questions, which are very commonly asked. And the second one is theory based, which dwells into syntax, database theory, optimization, or your experiences. In the live coding questions, today we'll be solving the basic questions, which have a difficulty from basic to intermediate. And there are 4 levels. We'll try to cover the first 3 in this series. So to practice these questions, you can use any online platform. But the questions we are going to practice requires data that are already present on the apps and data hosted MySQL server. I'll be live coding the questions on this platform to show you how you can leverage this platform. There are different tables present in the database: e-commerce sample, that is customer, category, employees, order detail, orders, products, shippers, suppliers. I request you to go through each and every table to understand what different variables and keys are present in these tables. Okay, enough of talks. Let's dive in straight into coding. So let's say if you want to solve the first question, where we want to find the customer IDs with the number of orders sorted in descending row. So here the table uses order. So let's dive into the platform. So first of all, we can click on order to get all the data variables that are present in this particular section. Now let's start writing our code. So we want to calculate the number of order for each customer ID. So we want customer ID. We want to have count of order. And in this case, we could do order ID from orders. And then we need to group by the customer ID just to see if this query is working or not. This query is working fine. Now let's do some aliasing. After that, we are also required to sort it based on the order count. A quick way to do it could be like using order by 2 and obviously descending. Now the order by 2 helps us select the second column and sort it based on the second column in the select statement. A much better and a sophisticated way to do it could be using the exact alias. And here we go. And this is how we have solved our first question. Okay, now let's dive into the second question. The second question is obviously the continuation of first one, which asks us to find the customer ID with maximum number of records. Okay, so let us assume that there is only a single customer with highest order count and there are no ties. So how we could easily solve it? So we just want to fetch the first row. The most easiest way to do it is using a limit of 1. So the same query, but just putting a limit of 1. Now, coming to a more sophisticated and a complex solution. So let's say if there are some ties in the table, so the correct way to solve it could be using a subquery. So let's see how we do it. So here, let's remove limit, run the query again. So here, what we really want to do is first fetch the customer ID with maximum order count. So for that, we need to calculate the maximum order count. So one way could be selecting the max of order count from this table. And probably we don't need order by in this particular scenario. We can keep it or we can remove it. Order by is an expensive operation. For the efficiency of query, we can also remove it. So let's see how much maximum order count we have. Probably I need a aliasing. So once we run this query, we are going to get the maximum order and the customer ID for which we have the maximum order. Now, what we really want to do is look for all the customer IDs having the same order count. So for that, we can write a subquery within a subquery. So we can select this and then we can use having order count in the max order count from this table. And this is our final result. We get the customer ID and the order count. Let's come to the third question. The third question applies joins between two table, order and customer. So it asks you to find the customer name, customer ID with number of orders sorted in descending order. So the output should look something like this: customer name, customer ID, and order count. So the tricky part to this question is to apply a join and a group by in a single statement. So let's see how we are going to solve this. So first of all, we are going to select the tables that we want. So obviously it's order and customer. Okay. So let's call this table A. Then we can put inner join of customer with order. But before we do that, we just need to see what are the different variables that are present in order. So order have customer ID and customer also have customer ID. So this could be the joining key between the two. So let's continue. So we are saying select star from customer as A, inner join order as B. We can probably use the same casing and then ID. And let's see what we get. Okay, now in this final table, we want to perform a group by operation because there were 3 specific columns required for our output. So the first thing that we are going to do is we are going to use the customer name from the first table. Then we are going to use the customer ID and then simply the count of all the distinct order from the second table. And we'll call that as order count. Now, once we do that, we have to use a group by, and we group by based on the customer name and the customer ID because it's an aggregation operation. And you can also put The aliases, because customer ID is present in both table A and B, so that could cause you uh, ambiguity error. And finally, the order by. Let's see if it runs. And finally, we get our result after running this query. Just a reminder, we should use the same case in here, otherwise it can throw an error. So when I was using a dot, it was throwing an error. Ideally, it should not, because we all know that SQL is not case sensitive, but after changing it, it's working fine. In the fourth question, we need to find customer name, customer ID with number of products they purchased in a single order transaction, and all of it sorted by descending order. So after looking at the data, you'll know that we'll require three tables. The first one would be order details for the order ID. The second one would be orders for order ID. And the third one would be customer table, which would be for the customer name and customer ID. So let's see how we are going to solve it. So first, we select everything from order details. Let's call it A. Then put an inner join with orders, call it B. And the common key between order details and order is order ID. So we are going to use that. Then we are going to put another join for the customer information with the customers table. And for that, we'll require customer ID. And finally, we can see if this works. My apologies, we have used as, we should use on. Let's see if this works. Okay, this works. So we have all the things that we require. Now, first of all, we need to extract some specific columns. So the first column demanded in the question was obviously customer name. So the customer name will come from table C, which is customer table. Then we can take customer ID also from customer table. That's fine. And then we want order ID. So order ID is in the order table, which is B, aliased as B. And then what we want is we want to calculate the count of distinct product per order ID. So we are going to count distinct different product ID, and we'll call that as number of product. Could be anything, doesn't really matter. And once we do that, we can group by based on one, or probably, yeah, 1, 2, 3. The first three columns of the select statement. So this is a very rude way to write, but still a short form. So, you could see people using it. And essentially, we want to order it by the fourth column. So one way to do it is this one. Let's see if this runs. It is running correctly. We can also use DESC in front of it just to have the highest one at the top and the lowest one at the bottom. So this is working perfectly fine. Now let's replace it with more sophisticated variables so that the readability of the code increases. So if you do this and this, the output should be the same. Let's run that. It's running. So this query might seem very long, but at the same time, it's very simple and very logical. So it could be easily asked. Now let's move to the fifth one. Okay, so we want to find the average orders per total customer for every employee ID and filter the ones which have value greater than 1.8. Now for me, it's easy to find the exact table, but we can also explore how we can navigate that. So let's say if you look at order details. Now, order details do have product ID and order detail ID, but it doesn't have the employer information, the employer that is selling that particular order. So let's go to the order table. Okay, now here we have customer ID, we have employee ID, and also the order ID. So I think this might be it. So to solve the particular question, which seems very complex, is the average order per total customer for every employee ID. So essentially, employee ID would be a grouping variable. Then average order and total customer will be your aggregated variable. So if we want to aggregate total customer, aggregate average orders, and then group it based on employee ID. So let's see how we can solve it. So to solve it, we'll use uh, first we can use employee ID, because employee ID is the one variable where we really want to group it on. So employee ID, and then we could do count of distinct order ID. And since we want to calculate the average, we could also divide this by count of distinct customer ID. All right, and that could be called as average order per customer from the table orders, no join required. And then we can group by employee ID. And let's remove this and let's see if this runs. Okay, so essentially if we are using order, it's giving an error, although it should not, because it's not a case sensitive, but we can always check. So if we use order, it's not giving any error. So the question asks us to specifically filter the one that is having value greater than 1.8. So let's see how we are going to put that filter. For that, we can use a having, and in the having, I have shortened the name just for the ease of writing, and we can say it should be greater than 1.8. And let's say if we done, we get this result, and again we can order by average in descending, and this gives us the final output. Okay, moving to the sixth question, we want to find the number of orders by each employee ID on month-by-month basis and place the premium customer flag on customer which have more than 5 orders on month-by-month basis. So if you look at this particular question, you could see employee ID, order date, order month, order count, and wherever the order count is greater than 5, we are giving him or her a premium customer flag. So let's see how we solve this. So first of all, we'll open the order table because we know we have everything that we need in the order table. So, okay. Now, the tricky part in this question is using some inbuilt date function. So we want the aggregation to happen on employee ID. So that would be again our first variable. Then we want to know the year, because we want to do the calculation on month-by-month basis. So as year, and then we would also require the month, because the grouping should consist of both order year and order month. So this is essentially year, you could call it month simply. And then what we want is count of order ID as order count from the orders. And again, we want to group by based on 1, 2, and 3. And you could order by, let's say, different order. It could be like 2 and 3 and 4, and the fourth one we want it, descending. So I'll just run this query. So what does 1 2 3 means? 1 2 3 again means employee ID, year, month, and 2 3 4 means, so essentially we have 4 elements, 1 2 3 and 4, and these tells you the exact same indices, but again we'll try to make it more readable, so we'll replace it with proper columns that we want. So we want these and this, and let's see if this runs. Okay, a better way could be removing the aliases, or removing the actual name. You could use the one that we have aliased. We can also remove the aliases from here. Okay, now it runs fine. Now, what we really want to do is put a case when statement to see if the order count is greater than 5, then we want a flag. Now, this type of coding is highly useful when you are building a data science project where you want to build flag variables. So let's see how we can use. So we say case when, again use the aggregation here and say if the count of order ID is greater than 5, then 1, else 0, and end as a flag of premium customer. And let's see if this runs. All right, so we have solved this question also. Now this question is a continuation of the previous question. In the above table, we want to use an inner join to filter employees that were born post 1960. So let's see how we are going to do that. So the output will remain same, but the employees should be born post 1960. So let's go to this table. We can preserve this particular query. The only thing that we need to do first is actually go to the employees table. So we'll copy this query and go to the employees table. In the employees table, we have the birth date. So we are going to kind of tweak it. So we only need the employee ID from employees where the year of birth date is greater than 1960. And let's see if we get that. So these are those employees that have birth date greater than 1960. One way to solve this query is to use a subquery. But here we specifically want to use inner join because I want to show you how we can use inner join as a filter. So we put this into a table, we put an inner join with a query that we have written previously. So it was in my clipboard, so I've just copied it back, the same query that we have written previously, the exact same one. We call it B, and we put a join based on employee ID. And once we do that, we should be reminded that we have used inner join, and then we say we want to select all from the B table, our previous query, and our previous query is kind of stored in, let me just long it, and you could see this is our B table, and we want to select stuff from all the records from B, but those will be filtered with employees having birth date greater than 1960. Let's see if this runs. Okay, now we have those employees. that we really wanted to. So we can scroll down and look at other different employees. So we can see that these are exactly the ones that we saw, which is 1369. So these are the employee IDs that are a little younger and their birth date is greater than 90, 60. Now coming to the last question, which is one of my favorite ones. So let's say if you want to compare sales of different product by developing pairwise table. For example, first record should be one product sales compared with other product sales. The output should look something like this. So we have product one. Product one could like a product ID of 2, 3, 4, 5 compared with product 111, and you can see the overall sales is compared with the overall sales of product two. Now, this is one of the most commonly asked question, and it is based on cross joint. If you are giving any competitive or uh, interview, you'll see that cross joins are the most important one. They are mostly used when we want to trace the employee ID, the manager ID. So in that kind of questions, it's used a lot. So let's see how we are going to solve it. First, we'll clear our slate and then we'll straight dive into. Okay, so first of all, we'll go to the product table. In product table, we have product ID, product name, category, unit, price, and everything. Okay, now this doesn't gives us the quantity, so we might have to look at a different table, probably order detail. Order detail has product ID and quantity, so order detail will work for us. So our first, uh, you know, method that we could use to solve the given question is to create first single table. So the first output that we want is having product ID and sum of quantity from order details and simply group by, you could say, product ID. Okay, let's run this. So we have product, we have the sum of quantity that it has, and let's do one thing. So let's call this as sales for the first kind of product, and we call this as, let's say, product one. That's good. Now we want to have a pair by pair comparison. So essentially we'll have to create two tables that are lookalike. So what I'm going to do is I'm going to copy this same and write the query again. But this time I'm saying that this is product two and this is sales two. That's fine. Now we want to put a cross join because we don't really have a key on which we want to join. And we'll call this as A and we'll call this as B. And we want everything from this. So we are going to do select star from this. Let's see if we run it. So now what we see is product one is being compared with product one. This is something that we don't want, but we want two compared with one. So for that, and to remove duplication, because there will be like 2, 3 and 3, 2. So to remove that, we can use a simple hack. We could say that the product ID 1 should always be greater than product ID 2. And once we do that, we have the same output as we see in results. And this removes the duplication, and you're comparing product ID 2 with product ID 1 and so on. Now, moving to adding one more layer of complexity to this, I can ask, like in the previous question, find the pair of product with the highest difference in sales. So if you see here, product 1, product ID 60 and product ID 9 has a gap of 1482. So let's say if we want to calculate this gap, we want to subtract the sales from product 1 and product 2. How we can calculate the gap? Now, one thing that we want to take care is, let's say if 95 is on the left side and 1577 is on the right side, the gap will remain same because the gap is nothing but the absolute difference. So the sign shouldn't matter. So let's see if we can solve that in the given query itself. Okay, so we have this query. The only thing that we want apart from the select star is adding a gap. And for the gap, the first thing that we need to do is we want to, kind of subtract sales 2 from sales 1 or sales 1 from sales 2. That doesn't uh, matter as of now, and we can call this as gap. Now, what's going to happen? Let's say if I run this query will run perfectly fine, but you could see some negative sign. Now, this is a gap of -229, and we really want that to be an absolute gap instead of negative or positive sign. So let's say if I do, so these are now converted into positive signs. Now we want to find the one with the highest gap. So very simple, we'll do it order by gap descending, and we could limit the query to 100 just to make it more efficient. So the query looks something like this. Let's run it, and product 60, product 9, 1482. If you look at the solution, that is quite relevant now. The query is good to go. Okay, so on final note, we have solved these 9 questions very quickly. You can practice these questions again and refresh your logic. Also, you can enroll yourself in any SQL question solving platform and solve multiple questions before your interview. Now, this will help you remain calm and your hand will shake a little less once you practice more. Hope you have a nice day. Follow, subscribe this channel for more such content. Thank you.